It's Damiano Zanotto. He's from Stevens Institute of Technology. He's actually one of our TC junior co-chairs, and he's presenting one of our TC initiatives, which is about the educational material, and he will speak about it now.
Hi everyone, I'm Damiano Zanotto. I'm with the Stevens Institute of Technology. My talk is a little bit different from what we heard so far, and in fact I'm not here to present a new mechanism or a new robot. I'm going to introduce a new open course on advanced design of mechanism and actuators for robotics. This is an open course that is currently being developed by our technical committee under a SAMRA award from the IEEE Robotics and Automation Society. So what motivated us to develop these new educational materials is the increasing use of unconventional mechanism, actuators, and transmissions in robotics. And in the previous talk, we really saw some excellent examples of those mechanisms. Unfortunately, the traditional graduate level courses do not really cover these topics. And so our graduate students, PhD students, and also researchers and engineering professionals have to rely on sparse literature in order to educate themselves about these topics. So we come up with this idea of designing a new open course that will be freely available to the community, will be maintained by our technical committee, but it will be open to the contribution from the IEEE Areas Society. The main topic, the main theme is on advanced design of mechanism and actuators for robotics applications. We included both the theoretical foundation and also design and this, analysis methods. And in addition to this more theoretical contents, we also included case studies taken from the literature. The structure is very similar to a graduate level course. Basically, we included a number of self-contained educational models that will be shared with the community in the form of PowerPoint slides that can be adapted and edited by the users under the Creative Commons agreement. The target audience is primarily graduate level students, but we believe that those contents will be also very useful to faculty members and professional engineers and roboticists. These are some of the representative topics that we have included in the course materials, and that really reflect the core areas of expertise of our technical committee. We included underactuated, compliant, and flexible mechanism, parallel robots, cable-driven robots, and then compliant and soft actuators and transmissions, and so forth. This is what we have developed so far. We have 11 modules. Each module consists of 50 to 60 slides, and they are all organized in a coherent format. The current modules will be made available on roboticscourseware.org and also cross-referenced in our TC website very soon. We are currently working on the terms of use documents, and after that we'll be ready to share with the community. While we are very excited about sharing this educational material with the robotics community, we also understand that these contents can be improved, they can be expanded, and for that we really need your help. And that's why we are calling for contribution from the community. If you have new ideas for a new topic that is currently not included in that list, please feel free to reach out to us. You can send us an email at this address. You can also maybe send a note on the chat box later on. We will be happy to include you among the contributors. Also, if you are an expert on one of the areas that I mentioned before and want to provide feedback on the current contents, please reach out to us, and we will be happy to share with you a link to the current shared materials. In that way, I'm sure that we can use your feedback to improve the contents. With that, I'd like to acknowledge the contribution from my collaborators, Aaron, Matej, Claudio, and Marco. And I thank you for your attention, and please feel free to reach out to us if you want to be part of this project.
Thanks a lot, Damiano. With your talk, we're also closing the second session.